The last absolute value equation we're going to look at is an equation that has multiple absolute values in it. So let's talk about solving equations with multiple absolute values like we have here. In example 6, we have the absolute value of 4x minus 3 is equal to the absolute value of 2x plus 7. So at first this can be a little bit confusing. Let's go through some possibilities here. You might think, like we did in the previous video, that all we have to do to drop the absolute value is introduce some plus or minus signs. But we have absolute values on both sides. So at first it seems like there are 4 possibilities. Let's go through them. So let me actually write that out. When rewriting this equation, it seems to have 4 possibilities. Oops, I can't spell. Possibilities at first. What am I talking about? Well, look, we know that the absolute value makes everything positive or 0. It's never negative. So what's inside these absolute values, like 4x minus 3, whatever that number is, it could be positive or it could be negative or 0. And whatever is on the right side could be positive or negative or 0. So case 1, both are positive, in which case we just drop the absolute value, bars. So that might look something like this. 4x minus 3 is equal to 2x plus 7. Okay, that's easy enough to solve. We'll solve that later. No big deal. Case number 2. The first is negative. The second is positive. So that might look something like this. We have 4x minus 3 on the left. We have 2x plus 7 on the right. And we might encapsulate this and say, well, you know, if that left side, the absolute value of 4x minus 3 can be positive or negative, if it's negative, we have to consider the possibility that the whole thing's negative. So there you go. And that wouldn't be too hard to solve. And we'll do that later. Case 3, the first is positive, but the second is negative. And so what we would have is 4x minus 3 is equal to 2x plus 7, where we interpret the absolute value of the right side as being opposite in value, negative. So we have 4x minus 3 is equal to the negative of the quantity 2x minus 7. Or case number 4, both are negative, in which case we would have 4x minus 3, quantity being negative, is equal to the 2x plus 7 quantity being negative. But it turns out there are only 2 cases, because if we took this bottom case, let's look at case 4 first. We could distribute the negative sign on both sides of the equation, or we could divide both sides by -1. And what would happen there? Well, those would both become positive. And then this is real. This, let me use a highlighter here. This is really the same equation. So case 1 and case 4 are really the same case. Case 1 and case 4 are the same equation. Similarly, if we were to take case 3 and divide both sides by -1, that would make the right side positive, but it would make the left side negative. And again, we would see that these two cases are really the same case. So case 2 and case 3 are really the same case. So what this boils down to is, for a result, either 4x minus 3 is equal to the positive version of 2x plus 7, or 4x minus 3 is equal to the negative version of 2x plus 7. That is to say, both sides have the same sign or they have opposite signs. Those are the only two possibilities. So when we go to solve this, what we have is 4x minus 3 is equal to 2x plus 7, in which case if we subtract 2x from both sides, we get 2x minus 3 is equal to 7. And if we add 3 to both sides, we get 2x is equal to 10, making x equal to 5. That was the original case number 1. For our second case, I guess it was really case number 3, but it's our new case 2. 4x minus 3 is equal to negative of the quantity 2x plus 7. Don't forget to use parentheses there because you're going to have to distribute that negative sign. And what we get is 4x minus 3 is equal to negative 2x minus 7. And we'll add 2x to both sides so that we get 6x minus 3 is equal to negative 7. And then we'll add 3 to both sides so that 6x is equal to negative 4. And we'll divide by 6 and we'll get x is equal to negative 4 over 6, which is the same thing as negative 2/3. And so we only have two answers here. X equals negative 2/3 and 5. So as far as guidelines for these types of equations go, it's really the same, more or less. Although you don't have to worry about does it make any sense because the right side and the left side are both in absolute values. So they're both going to be equal to each other at some point. So take the equation, drop the absolute values, and use plus or minus on the right side. And solve them separately. So let's write those guidelines down. Guidelines. If you have the absolute value of expression number 1 is equal to the absolute value of expression number 2, then you drop absolute values and write whatever expression number 1 is equal to plus or minus expression number 2, and that will generate two equations. Expression number 1 is equal to expression 2, or move this over just a little bit. Expression number 1 is equal to the negative of expression 2, and then solve both equations. All right, folks, well, we already did an example, so I'll leave the rest up to you. You want to take a look at that homework and work on that guided practice. and I'll see you guys next time.